Hey, folks, we're going to talk about complex numbers today. It's on page 48 and 49. And as it says, every complex number can be written as a plus bi. Might look strange, but that's how it is. There's a real component, the guy without the I. There's an imaginary component, that's the guy with the I. That's as simple as that. You could write 3 minus 4i, that would be an example. 3 would be the real component. Negative 4i would be the imaginary component. And these numbers just have to be real numbers. In other words, any number you can think of is fine. Let's pause it, get this done, and we'll move to that next section. What does all this mean? Well, what it actually means is that literally any number you can think of is a complex number. And why is that? I mean, literally just think about any number at all, even the number 1. That number is a complex number, but the imaginary part up here is 0. Or similarly, the number minus 5i, that's also complex. And again, the real part is 0 in this case. Get that down, we'll move to the next section. So we're going to continue. Again, pause if you didn't get that last part down yet. And so here we have the imaginary numbers part, right? So we talked about this barely, but a little bit before. And our definition is just that I is equal to the square root of a -1. That's just what it is. Well, if that's true, let's think about what this I squared might be, right? So let's take that definition, and that's a square root of a -1. We're going to square it because that's what I squared would be, right? Squaring it. And notice what happens. The square roots are going to cancel, and I'm just going to be left with a -1. So I squared equals a -1. All right, so pause and try to do this I cubed on your own. All right, pause it and then come back to it. All right, welcome back. So I'm going to think about I cubed as I squared times I, because that's the same as I cubed, right? 2 plus 1 is 3. And we know what both of those are. We know that I squared is a -1. We just figured that out. And we know that I is the square root of a -1. And so we found that this is equal to a negative square root of a -1. So we could leave it like that, or honestly, it's just better to leave it as -I, right? That's just simpler. So we've got I squared as a -1, I cubed as just a -I. Again, pause it and see if you can figure out I to the 4th. All right, here's I to the 4th. I'm going to think about this again, just like I did I cubed, as I squared times I squared, because that adds up to 4, makes it easy on us. And we know that I squared is a -1. So it's really just a -1 times a -1, which is +1. All right, pause it and we'll move to that next section. And right here are some examples. These are all examples of complex numbers: 7, 4 minus 3i, 1000i, pi minus ei. If we haven't talked about the number e yet, we will. -3/5, 0.01 plus 0.1i. Those are all examples of complex numbers. That's all that is, just some examples. And then for this last section, what we're going to do is simply just follow direction. So it says to add 3 minus 4i to a -10 plus 17i. So we'll go ahead and do that. 3 minus 4i plus, this is to add, a -10 plus 17i. And this is just super basic, right? We just need to think about which are like terms. And like terms are, we're going to add the real stuff together, and we're going to add the imaginary stuff together. So let's start with the real stuff. The real stuff is +3 and -10. So what is +3 minus 10? -7. I'll just highlight that too so it's clear. 3 minus 10 is a -7. And then, well, what's left? We have a minus 4i plus 17i, minus 4i plus 17i, and that's going to be plus 13i. And that's it. We just want to simplify. We're simplified. We're done. All right, we'll go ahead and move to example 2. Example 2 says to multiply these. You can use whatever method makes sense. You can think about it as really not any different than multiplying like x minus 1 times x plus 2. Whatever method you would use for that is fine. So you could use FOIL and do the arrows like this. But I've found that in my later years, I like to stay organized with a nice little box. So I'm going to draw a sloppy box over here and write 3 minus 4i and a negative 10 and 17i. And hopefully that box is big enough. And then I'm just going to multiply the spaces together, right? So a negative 10 times 3 is going to go here. That's a negative 30. A negative 10 times a negative 4i. Negative times a negative, positive. 10 times 4, 40. And there's that I. 17i times 3. It's going to be an I. And then 21, yeah, so 51. 51i. And then 17i times a negative 4i. So it's going to be negative. 17 times 4. Oh, I don't want to do that in my head. So I'm just doing it on the side real quick. 68. That's going to be a negative 68i squared, right? Negative 68i squared. All right, let's put it together. We'll start with a negative 30. And then we have plus 51i plus 40i and minus 68i squared. So we're just going to combine them. These middle ones combine, that's a negative 30 plus 91i. And then here's what I want you to remember, right? What is I squared? We look back up, I squared is actually a negative 1. So this negative and this negative, right? Because those are both negatives. That gives us a double negative. What is a double negative? Right? It turns into a positive. So it's actually, we're adding 68. So what is a negative 30 plus 68? Oh, that's positive 38 plus 91i. And that's it, we're done. Right, so get that down and then we'll look at the example problems. Here are the example problems. It exactly matches what the notes were. You can see that these numbers are 5, 8, and 11. I think that's the only thing that might be hard to see. Again, just log on, let me know. All right, I'll see you guys in class.